All right, for the calculator portion of this chapter 3 review, the first thing we're working with are the compound interest formulas. So this says given an initial investment of 5,500, that's the principal, into an account that pays an annual interest rate of 2.25%. So change that to a decimal. R is 0.0225. Answer questions 36 to 38. Round dollar answers to the nearest cent, which is 2 places. Round time answers to the nearest thousandth, which is 3 places. You'll be prompted to do the same on the test. Find the balance in the account after 15 years. That's T. If the interest is compounded first semi-annually, that's when N is 2. Quarterly, N is 4 times a year. Monthly, 12 times a year. Daily would be 365. We don't have that on here. Continuously, we're going to use the PERT formula, P-E to the RT. All right, so the setup here, the balance is 5,500 times 1 plus 0.0225 over 2, raised to the, it's NT, but I'm going to write 15 times 2 so that I can change things. Make adjustments in my calculator. Now, I keep showing that, like, I just keep retyping this and making adjustments here. You could also type into your y equals. You don't have to do this, but if you had a lot of these to do, you could type the equation into your y equals where you put in x for the position of n, and then you would just say find y1 of 2, find y1 of 4, whatever. I'm not going to do that because I just want to keep things consistent, but you can try that if you want to. 1 plus 0.0225 over 2 raised to the 15 times 2 power. I know that's 30, but I'm just going to, like I said, I'm just going to write over the 2's. So just trying to give myself the least amount of typing as possible. Round this to the nearest cent. So this is, split this, 7,600 and 93.41. All right, the only adjustment to the quarterly formula is now we're doing 5,500 times 1 plus 0.0225 over 4, raising it to the 15 times 4. So on my calculator, I can just grab this line and press enter, change that 2 to a 4, and change that 2 to a 4. So now we get 7,700.63. Should be in the same ballpark as the other number. We've got about $7 more, it looks like. So that's good. And then now we need to change things to monthly. So for monthly, again, it's still the 5,500, 1 plus 0.0225 over 12 to the 15 times 12. So again, I can get the previous line. It's easy to change the 4 on the end to a 12 because you don't overwrite anything. But remember, we learned about this insert feature here. If I just type 12 right now, it's going to overwrite those parentheses. So do second delete for insert. Type in the 1. So that inserts a place. And then you got to arrow out of that to get it to stop inserting. And then make that a 2. So now we're at 7,705.48. And then for continuously, now it's different formula. It's the PERT formula. So 5,500 times e to the 0.0225 times t, which is 15. So no n to type in for continuously. So this one just has to get typed in fresh. And we get, the pen doesn't want to work, 7,707.92. So again, none of these, if you ever notice that your If you ever notice that your answers are wildly different from one to the other, there's probably a typo happening, or maybe you have something wrong with the formula. So definitely pay attention to your answers. 37 says, if the interest is compounded continuously, how long will it take for the initial investment to double? So we do have the initial investment here, 5,500. So you could double that, set it equal to 11,000. Or it doesn't really matter how much was initially invested. If the initial investment is P, then double that is going to be 2P. And this is continuously. So e to the 0.0225 t. Question is how long, so solve for t. The first step for solving an exponential equation is always to get the e by itself. So you're going to divide the p out and get 2. Even if you did take the time to say 5,500 and 11,000 here, and then divide, they're still going to divide out to 2 in the end. So you should get to this equation. And then to solve that, we need to natural log both sides of the equation. Taking the natural log base e cancels out, so 0.0225t equals the natural log of 2, and then you divide by 0.0225 to solve for t. So this is an answer for time, so I'm going to round to 3 places. So that was natural log of 2 divided by 0.0225. So about 30.807. And time is always measured in years for these compound interest formulas. If the interest is compounded quarterly, how long will it take for the balance to reach 8,000? So here I do need to, because I'm not just doubling or tripling, I do need to put in 8,000 for the balance, and I started at 5,500. This is not the E formula, this is compounded quarterly, so 1 plus 0.0225 over 4 to the 4t. Now I need to solve this. I could solve this by graphing, but I think it's faster. We're pretty good at solving our exponential equations now, so it might be faster instead of messing around with the window to just go ahead and solve this algebraically. So the first thing is to divide. Now you do have a calculator, so if I divide 8,000 by 5,500, that's essentially 80 divided by 55. That's 16 over 11. And I could do the math right here, right? Like what is 1 plus 0.0225 over 4? Now, if you do the math here, do not round this number. So you would need to keep this as 1.005625. Or if you don't do the math, just leave it like that to the 4t. We're going to log or natural log both sides. The base is weird. I would not want to log this base both sides. I mean, I guess you could, but I'm just going to natural log both sides. Natural logging this base number does not cancel out the base number because they're not inverses of each other. So instead, I'm going to bring the 4t down in front. It's still natural log of 16 over 11 over here. To solve for t, divide by the 4 times natural log of 1.005625. Okay, so let's see what that is. So that was the natural log of 16 over 11 divided by, be careful here, you need parentheses, around 4 times natural log of 1.005625, because otherwise the calculator will do order of operations. It would only divide by 4, and then it would multiply the answer by that. All right, so rounding to 3 places, 699 rounds up to 700. So this should be t is about equal to 16.700 years. If you're not sure on the rounding, take it to more than 3 places and then round wherever you stop, round it correctly. All right, now we're given a function. So the function f of x equals this models the percentage of surface sunlight which is f of x, that reaches a depth of x feet beneath the surface of the ocean. Like how much sunlight comes through if you're underwater. What percentage of the surface sunlight reaches a depth of 50 feet? So they're asking us to input 50, and what is the output? So basically find f of 50. So you should just be typing in 20 times 0.975 to the 50th, and we'll round to 3 places. You're always rounding to 3 places unless we're talking about dollars or unless they tell you otherwise in the problem. So 5.640, and this is a percent, so I'm going to label it with percent. So about 5.6% of the sunlight is coming through. At what depth is 1% of the sunlight visible? So because my answer for part A was 5.6%, I should be setting the equation equal to 1. That's 1% equals 20 times 0.975 to the, not to the 50th, to the x. We need to solve this for x, so isolate the exponential term. I'm going to natural log both sides. Again, you could solve this by graphing. Where do these two things intersect? You could use log base 0.975 if you want to. You've got to know how to type that into your calculator. Pull the x down. And divide. So let's see what depth that is. The natural log of 1/2 divided by the natural log of 0.975 is 27.378, and x is measured in feet. All right, new function. The function p of x models the percentage p of x of students who can recall important features of a classroom lecture as a function of time. X represents the number of days since the lecture was given. How many days will it take for only 50% of the students to recall important features? So again, do I set this equal to 50 or 0.5? It's probably 50, right? If we plug in 1 for x, log base 2 of 1 is 0. So when x is 1, p is 95, meaning after one day, 95% of the students recall important information. So we need to set this equal to 50. All right, and now it's just solving a log equation. So again, you could solve by graphing, but it's kind of hard to type in log base 2 of x. So I would just subtract 95. Isolate the log, divide by -30. So 45 over 30, if you reduce both of those by what, 5, you get, or no, by 15, you get 3 over 2. You don't have to reduce because you're going to be typing it into your calculator, but I just think it's less to type. How do we get rid of log base 2? We base 2 both sides. So it's 2 to the 3/2 equals x. And let's get that as a, 2 to the 1.5, 2 to the 3/2. Get that as a decimal. So how many days? Only 2.828 days. So quite the rapid, after one day, I just said 95% will remember. After less than 3 days, only 50% will remember. So that's great. Okay, on to the next thing. The half-life of thorium-229 is 7,340 years. How long will it take for a sample of the substance to decay to 20% of its original amount? Now, this formula for half-life is some sort of original amount times 1/2 to the time over half-life time. So in this case, half-life time is this number here. And we're saying we're going to get 20% of the original amount. So if the original amount is A, we want 20% of A in the end. So here's my model to begin with. We're raising it to the t over 7,340. This is just like doubling your investment. It doesn't matter what A is. You're getting 20% of A. You're going to divide A out. So 0.2 equals 1/2 to the t over 7,340. I can natural log both sides. I can log base 1/2 both sides, whatever. You just have to be able to type it into your calculator. So I keep saying that. So I like to just keep natural logging both sides. Makes things a bit more consistent. That way you're kind of doing the same thing over and over. I pull the exponent out in front. T over 7,340 times the natural log of 1/2 is equal to the natural log of 0.2. Solve for t. So if this is natural log of 1/2 over 7,340, you multiply by the reciprocal to get rid of those two things. So this is t. So let's see what that's approximately equal to. 7,340 times natural log of 0.2. Divide that by natural log of 0.5. And, oh, pretty long time. 17,042.952. T is measured in years for all of these half-life problems. All right, that makes sense. It's got to be more than 7,000. 7,000 is when we would be down to 50%. So we're asking when will we be down to 20%? It's going to take longer. The logistic growth function, this, f of t, describes the number of people who become ill with influenza t weeks after the initial outbreak. How many people became ill with the flu when the epidemic began? So this is the same as like the initial amount. Initial means t equals 0. So evaluate f of 0. That would be 100,000 divided by 1 plus 5,000 times, it's e to the negative t, but that's still e to the 0. Now, e to the 0 is just 1, right? So really, this is just 100,000 divided by 5,001. Oops. 1 plus 5,000. Round to the nearest person. So let's see what that is. 100,000 divided by 5,001. Okay, so 20 people about. Okay, so that's what we're starting with. How many people were ill by the 4th week? So that's asking you to find f of 4. That will be 100,000 divided by 1 plus 5,000. E to the, it's negative t, so negative 4. Just be careful typing this in. When you're typing into your calculator, make sure that's 100,000. Anytime the denominator has more than one number in it, you've got to put parentheses around it. So 1 plus 5,000 e to the negative 4. Close them. We get 1,000, again, round to the nearest person. It doesn't say that, but let's call this 1,080 people. Right? How many weeks will it take for 10,000 people to become ill by the flu? So now we're setting the equation equal to 10,000. And you could solve by graphing. If you're going to solve by graphing, the only tricky part is getting that window to fit. But use your previous answers to help you figure out what window you should use. So when we typed in 4, we were only at 1,000. So you might be going like 0 to 20 or something. I'm just going to solve algebraically. I'm going to multiply the denominator to this side, but then I'm going to turn around and divide by 10,000. So it should be 1 plus 5,000 e to the negative t is equal to 100,000 divided by 10,000, which is 100 divided by 10, which is 10. Isolate e to the negative t, so subtract 1. Now it's 5,000 e to the negative t equals 9. Divide by 5,000. Natural log both sides. and get rid of the negative. So t is equal to negative natural log of 9 over 5,000. Negative natural log of 9 over 5,000 is, this is how many weeks, so we'll keep the decimals, 6.320. 6.320 weeks. Right? Last problem is a regression problem. We had this in some of our AP classrooms. The data below shows the amount of savings, the amount of savings needed for healthcare expenses during retirement compared to the age at death. So age at death, we've got 80 to 100. The amount of savings needed, we've got those various numbers. Use an exponential regression. Using an exponential regression, find the amount of savings needed for a person whose age at death is 87 years. So it's going to be something between 307,000 and 409,000. We're basically being asked to find f of 87. And we need a model to do that. So in your calculator, go to Stat, Edit. I've already got the numbers typed in. So take a minute to put the ages into L1 and the dollar amounts into L2. And then you're going to go to Stat, Calc, option 0 is exponential regression. You can just type 0, but I always like to show where it is. Remember, you want to evaluate with this without having to type in all the decimals, so store this equation into y1. That's alpha trace y1. Calculate. So it gives me this equation here. We can write it down if we need to, but again, if you're not going to store it in y1, you have to write down all the decimals. So that would be kind of tedious. Otherwise, I'm just going to, on my home screen, say, all right, take alpha trace y1 of 87, evaluate that for me. And it does. It's about equal to, there's split screen here. It's about equal to 334,196.15, because we're talking about money. That's about how much savings the model says a person who lives to 87 would need. An experimental population of mosquitoes is growing exponentially, which is this format. That's exponential growth. The initial population of mosquitoes was 100. So when time was 0, we had 100 mosquitoes. After 4 days, there were 165 mosquitoes. Show the work to find coefficients A and B without the use of a calculator. So no calc. This was modeled after an AP question, free response that I saw, and we had this in our notes too. In our notes, we did more with it, but for now, we're just going to basically just find A and B. Now, A is always the initial amount. So if they want me to show work for A, you always begin by plugging in the 0 point. 100 goes in for Y. We don't know A. It's e to the B times 0. Well, that's e to the 0. E to the 0 is 1, so A is 100. So that's easy. A is 100. Show the work to find B. Well, now that you know A, you'll be able to find B. So plug in the other point. 165 is Y. A we now know is 100. E to the B times X is 4. And then solve this equation. So divide by 100. 165 divided by 100 is 1.65. I'm going to write this as 4b. And then natural log both sides. And then divide by 4. So natural log of 1.65 divided by 4. So, oh wait, and we don't have a calculator, sorry. So I would just say b is equal to this. You also wouldn't have to do the division, or if it was uglier than this, you could leave this as natural log of 165 over 100 over 4, and that would be fine. All right, that's it for the calculator part of the review. Feel free to come into office hours if you want more practice or have questions.